Hello students, welcome to the new video series on electrostatics. In this chapter, I will explain some of the concepts as well as problems solved based on those concepts. Without further any delay, let's get into the concepts. So first of all, I have this electromagnetism. In that we have the three important categories. One is electrostatics, second one is magnetism, and third one is electromagnetic waves. So what is electrostatics? Electrostatics is the study of charges at rest. What type of charges are they? They are called the source charges. Here in electrostatics, we keep the source charges at rest. Then we will study the force due to these charges on a test charge. Let's consider I have a source charge here and a test charge here. This is source charge, is considered small q, and this is the test charge, capital Q. This will be at rest, okay, and this may be moving or may not be moving. We can keep this at rest, or we can consider this as moving charge particle, and we will find the force due to this charge on this test charge. So then we have the magnetism. What is magnetism? Magnetism is the study of charges which are moving, or the study of charges moving with some velocity. Okay, so then we have the electromagnetic waves. Here we study the charges which are accelerating. Okay, so these are the three categories of electromagnetism. In all these three chapters, we study about a fundamental particle that is called charge. What is charge? What are the properties of charge? Let's study them. If I consider any object, it will be consists of three different type of charges. One is positive charge, second one is negative charge, and the third one is neutral charge. But we don't consider the neutral charge because it is neutral. Okay, so we will consider only positive charge and the negative charge because they are more effective on each other. So what are the properties of those two charges? First of all, we have the like charges repel each other. If I bring a positive charge near another positive charge, they repel each other. Or if I bring one negative charge near the another negative charge, then also they will repel each other. What if I bring a positive charge near a negative charge, or a negative charge near a positive charge? They attract each other. Okay, so then the unit of charge is given by Coulomb. What is Coulomb? Coulomb is equal to the quantity of charge that passes through a cross section of conductor in 1 second. Okay, so here we have this smallest positive charge is equal to plus or minus E. That is equal to 1.6 into 10 to the power minus 19 Coulomb. From this I will define this Coulomb. Okay, so Coulomb is equal to what? 1 electron is equal to 1.6 into 10 to the power minus 19 Coulomb, right? So Coulomb will be equal to 1 divided by 1.6 into 10 to the power minus 19 electrons. That will be equal to 6.25 into 10 to the power 18 electrons. These are the number of electrons moved through the material in 1 second for 1 ampere of current. That is called 1 Coulomb. So then we have the smallest positive charge available in the material is 1.6 into 10 to the power minus 19 Coulomb. It cannot be less than that. And then we have the mass of the electron, that is equal to 9.1 into 10 to the power minus 31 kg, and the mass of the proton, which is 1.6 into 10 to the power minus 27 kg. Actually, the charges of both electron and the proton will be same but in opposite sign. That means the charge of the electron is minus E, that is equal to minus 1.6 into 10 to the power minus 19 Coulomb, but the charge of the proton is plus 1.6 into 10 to the power minus 19 coulomb. Because electron is negatively charged, proton is positively charged. The charges will be same but in opposite sign. But what about mass? The mass of the proton is almost 2000 times more than the mass of the electron. Okay, so then we have the quantization of charge. What is quantization of charge? If you consider a material, it consists of some charges that will be equal to integral multiple of E. If it is positive charge, that means if it consists of n number of positive charge, that will be plus Ne, or if that consists of negative charges, then the total charge will be equal to minus Ne. Then charge is conserved in an isolated system. This is the next point. That means if I consider a system, let's divide this into two types. Here I have some charges. Here I have some charges. Okay, if I give this charge to this one, the number of charges removed will be here will be equal to number of charges gained by this one. Okay, so here it will become, so here it has gained one charge, here it has lost one charge. Now then the mass of the electron is given by, or usually if the for a moving particle the mass is given by m naught divided by square root of 1 minus v square by c square. But here the velocity of the electron will be much less than the speed of light. Then we can easily write m is almost equal to m naught. Next we have the Coulomb's law. This gives the mathematical expression for force of interaction between two charges. So here I have considered two charges, one is Q1 and the other one is Q2. Since both are equal charges, that means both are positive, the force of interaction between two charges will be in opposite direction. The force F2 due to M1 is F21. The force F1 due to M2 is given by F12, and they will be in opposite direction because like poles always repel each other and unlike poles always attract each other. And here if you take this scenario, here the Q1 is positive and Q2 is negative. The force due to M2 and M1 is F12, and force due to Q1 and Q2 is, or M2 is F21. Since they are in opposite sign, that's why they are attracting in nature. So this is given by the formula F is equal to K Q1 Q2 by R square. Here F is directly proportional to Q1 and F is directly proportional to Q2 and F is directly proportional to 1 divided by R square, or F is inversely proportional to R square. So this is called inverse square law. As R value increases, F value decreases. Then here the K is called Coulomb's constant. That is given by 9 into 10 to the power 9 Newton meter square by c square. This is for free space because the Coulomb force or Coulomb's law is dependent on the medium. And K value is given by 1 divided by 4 pi epsilon naught. Epsilon naught is the permittivity of free space. Okay, so if you substitute this K value here, then we will get F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 by R square. And you need to know some of the facts about Coulomb's law. They are: the Coulombic force is always along the line joining the two charges. Here if you take, the force is along the line joining, it may be away from the charges, but they are along the line charges. If I take one charge here and the other charges here, it cannot be like this. Like the force of interaction between those two will not be like this because the line joining those two charges is like this. So force also will act away from them or towards them. Okay. That is one point. Next we have the force of interaction between the two charges is independent of the other charge or independent of presence or absence of other charge. That means let's consider two charges here, Q1 and Q2. Let's consider this one only. Two charges are there. I will put one more charge here. Let's consider that as Q3. The F12 is independent of Q3 or F21 is independent of Q3, I say. Okay, it is independent of that. If you want to find the effect of Q3 on Q2 or the effect of Q3 and Q1, we will do it separately. We will not involve the force due to this one and this one and this one. We will find the force due to Q1 and Q2 separately and force due to Q1 and Q2 separately, and we will add it. That is called principle of superposition. So here I have given that also. The principle of superposition of charges is defined as the net force on a charge in a system of charges is the vector sum of all the forces due to all remaining forces on that charge. So here I have given some n number of charges here, Q1, Q2, Q3, so on, Qn. These are all called source charges, and this is test charge. The force due to Q1 on Q is F1. The force due to Q2 on capital Q is F2. The force due to Q3 on capital Q is Q3. So on, the force due to Qn on capital Q is Fn. So by the definition of superposition of charges, forces of charges, we can write F is equal to F1 plus F2 plus F3, so on, Fn. Next, Coulomb's law depends on the medium. Remember this. Coulomb's law is dependent on medium. Then we have the inverse square law. Coulomb's law is also called inverse square law. That's why F is directly proportional to 1 divided by R square. If R is doubled, then the resultant force will become F divided by 4. If R is reduced by half, then force is increased by 4 times of its original force. So these are the facts about Coulomb's law. And we have some of the limitations of Coulomb's law also. Let's discuss about that now. So then we have the limitations of Coulomb's law. First of all, it is valid only for point charges at rest. If the charges are moving, then it is not applicable. In that we have two cases. What kind of charges should be at rest and what kind of charges can move? Okay, so here the point charges, in the sense the source charges. The source charges should be at rest and it doesn't depend on whether the test charge is moving or not. It can move or may not move, but source charges should be at rest. And then second one, it is not applicable if the two charges are under the motion. Okay, so third one, it is only applicable for those charges where inverse law is obeyed. I have already told you the Coulomb's force is inversely proportional to R square. That is called inverse square law. And the fourth one, it is difficult to apply Coulomb's law when the charges are in arbitrary shape. If the charges are in arbitrary shape, then it is very difficult to apply Coulomb's law for this shape. Okay, these are the limitations of Coulomb's law. So this is enough for this video. We'll meet you in the next video. Till then, take care. Bye bye.